Hello my dear learner, welcome to another mathematics lesson. The topic which we have been discussing is area approximation. In our last lesson we looked at the trapezium rule, and in that subtopic we learned how to find area of irregular shapes using the trapezium rule. In that trapezium rule, we normally assume each of the strips are actually a trapezia. Each one of them is a trapezium. Today we are going to look at another method or another way of finding area of irregular shapes. It is called the mid-ordinate rule. Today we are going to learn what we call the mid-ordinate rule. I have a chart here. There is a chart here showing a graph. In the horizontal axis, I have a square, 2 units representing a square, and for the y-axis or the vertical axis, the scale is again the same, 2 units for 1 square. So this area, the shaded area, is what we want to try to find by this method called the mid-ordinate rule. As you can see, the shaded area has been bounded by 4 boundaries or 4 lines. There is a straight line here, another straight line, and then a curve. In this method now, unlike the other method, we are going to assume each strip is actually a rectangle. That is what we are going to assume. We have already divided into 1, 2, 3, 4, 5. I have divided that region into 5 strips. But now we are going to assume that each strip is going to be a rectangle. In the other method, the trapezium method, we assume each strip is a trapezium. Now we are going to assume that each strip is a rectangle. If you look at this strip, for example, the first one here, it is not actually a rectangle. It is in the shape of almost a trapezium. But you are going to assume it is a rectangle. And remember, area of a rectangle is found by the formula length times width. The width here is clear. It's clearly known. But what length are we going to take? That is the question. What length are we going to take? Are we going to take this one here, which is longer than this other length? This length here is around 9 units. This one is around 7 units. So what we are going to do is we are going to get the average. Instead of taking this one which is longer and this one which is shorter, we are going to take a length which is in the middle. This one here, the broken line here, we are going to take that as our length, because that length is like average of the two. It's like average of these two. So we take the length which is in the middle, which is now called the mid-ordinate. This length here is what we call the mid-ordinate. So for the first rectangle, the area will be length times width. And I say this, we take the length, this length in the middle as the length. So in this case, this length is up to, that is around 7.8. So the length is 7.8 multiplied by the width. The width is this. It's very clear. The width is 2 units. So 7.8 times 2. That is the area of the first rectangle. Then the other rectangle, we do the same. The length we are going to take is the length which is in the middle, or the mid-ordinate. So this length here is 6.8 or 9. Around, I don't have small squares, but if you have, it has been drawn on a graph page, you may come to the small squares. So this is approximately 6.9. So 6.9 times 6.9 is the length multiplied by the width. The width is the same again, is 2, plus the area of the third rectangle, length. This one is now exactly 7.0. So multiply 7.0 times the width which is 2. The width remains 2. For every rectangle, the width is the same. Then plus the last one, or the next one, which is exactly 8. That is 8 or 8.0 multiplied by the width which is 2. Then plus the last one, which is the length is 9. The length is 9. So multiply 9 by 2. And then you now add. Remember, we have found area of each rectangle. So to get the total area of this figure, we add the area of the rectangles. Let us add very quickly. We can simplify because there is 2 which is common. We can multiply or factor out 2, then we add the lengths. We add the lengths. That is 2 multiplied by 7.8 plus 6.9 plus 7 plus 8 plus 9. We have factored out 2 because 2 is common to simplify our work. So that is 2 multiplied by, if you add all that, you will get 38.7, which is the same as, if you multiply that 8.7 by 2, you will get 77.4 square units. That is the answer. That is the area of that shape. Remember, here I have made it a bit simpler, but you can still find this area, multiply this by 2, get the answer, multiply this by 2, get the answer. The same for all the others, then you add. It's still the same thing. I just made it simpler here by factoring out 2. I hope up to there we are together, my dear learner. Now, this is a specific example where we have certain lengths. Let us now take a general case. A general case where this length is h. A general case where the length is h. This width is h. And this length, the lengths now, the mid-ordinates, we assume the first mid-ordinate is y1, the other ordinate is y2, the next is y3, y4 up to the last one. It is the ordinates now, the mid-ordinates, we start with y1. I don't want you to confuse with the trapezium rule. For trapezium rule, we start with y0, my dear learner. For trapezium rule, we start with here y0. Then you go up to yn for n trapezia. But for this mid-ordinate rule, we start with y1. The first mid-ordinate is y1, not y0. So you start with y1. So we shall have, therefore we shall have y1 times, let me write it here, area equals, the first one, y1 times h plus y2 times h, length times width, plus y3 times h plus y4 times h plus y5 times h. That is the area of the first rectangle, area of the second rectangle, area of the third rectangle, area of the fourth rectangle, then area of the fifth rectangle. In our case here we have 5 rectangles. So if we factor out h, because we have h common, we shall remain with h in brackets. We have y1 plus y2 plus y3 plus y4 plus y5. And that is what I have written here in the chart, you can see. So area is equal to h outside the bracket. Then inside the bracket we have y2, y3, y4, y5. So y1 plus y2 plus y3 plus y4 plus y5. So that is actually the formula which we use. That is the mid-ordinate rule. This is what we call the mid-ordinate rule for 5 rectangles. But if we have n rectangles, then this is the formula now. The one below, area is equal to h in brackets, y1 plus y2 plus y3 plus up to plus yn. For n rectangles, you will move up to yn, y1 up to yn. For example, if we have 10 rectangles or 10 strips, then it will be y0, sorry, not y0, y1, y plus y2 plus y3 up to y10. If we have 15, then it's up to y15. I hope that is clear. So this is what we call the mid-ordinate rule. This one here is what we call the mid-ordinate rule. So, my dear learner, we are going to look at examples in my next lesson. For today, I want to stop there. This is a bit easier than the trapezium rule. It is very easy to remember. You just factor out h, then in brackets we have y1, y2, y3 plus y4 up to yn, where n is the number of strips which you have, or the number of the rectangles. Remember, they are not actually rectangles, but we are just assuming that they are rectangles. Remember, the topic is area approximation. We are just approximating, we are estimating, we are not getting the exact area of that figure. So I will stop there. In my next lesson, we shall now look at examples of questions on this mid-ordinate rule and how to solve those questions. Have a nice time. Thank you for watching. Bye bye.